This one's about Gibbs free energy and calculating delta G. Now to get delta G, we use the formula delta G naught equals delta H naught minus T delta S naught. The delta H and delta S, we actually already got these previously. You can look at questions 1 and 2 to see exactly how we do that, but I'm going to use the same values as I obtained earlier there. So kilojoules per mole on the delta H, and delta S is 344.97 joules per mole per Kelvin. The delta G value then we calculate by subbing those values in. So delta G naught equals delta H, which is 118.34 kilojoules per mole. That's minus T delta S. Now we are given a temperature here, and that's at 25 degrees. That's going to be 298 K. Even if we use plus, over here I'll show you the calculation, even if we use 273.15 as our conversion factor, that's still 2 decimal places. That's 0 decimal places here. So the answer comes out to be 298K, which has no decimal places. So it's T is going to be 298K. That actually is part of the significant figures here in this instance, times the delta S value, which is 344.97 joules per mole per Kelvin. Now you can see what's happening here is that we've got two different sets of units. We've got kilojoules up here, but we've got joules down here. So what I'm going to do is convert this into kilojoules, and I do that by multiplying by 1 kilojoule over 1000 joules. Now you can see what's going to happen is that the kelvins will cancel here, and now the joules can cancel here, and we're left with kilojoules per mole, which matches the unit on delta G. Now this becomes, at this point, an addition-subtraction problem, but over here this is a multiplication problem. So this is subject to multiplication significant figure rules, this part here, but I'm putting the check mark on. Alright, so let's look at how we proceed. We've got 118.34 kilojoules per mole, and that's minus, and this will be minus 103 kilojoules per mole, which has been rounded to 3 significant figures to account for the temperature here. The temperature has 3 sig figs here. Now this is going to be 2 decimal places. That's no places past the decimal, so the answer comes out to be 15 kilojoules per mole.